Hello and welcome to another video. And today we have what is this? An MSI Mac X670, I think it was. That was, or Tomahawk. I'm not too sure. I cannot see the writing anywhere on what model this is. I can only see the MSI logo right here, which says MS7E12. So this is the internal model number for MSI. And this was sent in by a viewer. And something very interesting to happen to this board, which is that on this board there has been the wrong voltages in the wrong power rails. Someone has used on modular power supplies, the cables are not interchangeable between brands. So you cannot plug a Corsair one into a, I don't know, Gigabyte one, and vice versa, and so on, and with every brand. And someone has tried that and plugged it into this board, and a lot of things got shorted. He tried to diagnose some of the parts himself, but I guess that was just way too much for him. He sent me some pictures with some things where he already said, yeah, those are heating up or those sparked. And what we will have to do is we have to take all of the heat sinks off, measure each of the resistances from all of the power rails, and probably have to remove a lot of things that are shorted. And we will have to inject a lot of power and see what gets hot on the thermal camera. So let me get all of this off, because there's a lot of heat sinks. Like for the VRM, you have the M.2 and then also the PCH. It's a great board. It looks really cool, but yeah. Let me do that first. But before we get to disassemble the board, let me thank today's sponsor, which is PCBWay. PCBWay is your one-stop solution for actually producing PCBs that you've designed yourself, and also for assembling service. They offer a great service, and I've been partnered with them for quite some time now, and they've been sponsoring the channel, and they enabled me to make my very first own design of a PCB. This was for a 555 timer circuit that I was able to make, and this is basically a SMD footprint for the 555 timer circuit and for the passive components that I need. And this enabled me to make a circuit board where I take an input signal, and after a time output another signal to open up a MOSFET. And yeah, this was my very first time making a PCB, and PCBWay made it possible. I made the files for them, and they have quickly sent me a few of these boards out, and the quality of them is great. They offer a lot more services, like I think they also do CNC and also 3D printing. I've never done those services with them, but I can definitely say that the printed circuit boards are just awesome. The quality of them is just great, and they also have a really quick shipping time. Like, I was impressed when I got these, how fast they were able to make them. And yeah, in the future I will definitely be making some more PCBs, and I will definitely be taking PCBWay's offer on that, and will be doing some PCBs with them. So I hope you're looking forward, as soon as we will be making some more PCBs with PCBWay together. So after quite some time, now I got all of the heatsinks removed, and this is the first time I see two PCHs on a board. As far as I know, I have heard that X670E is using two B650 PCHs at once. I'm not 100% sure on that information, but that's what I've heard. And interestingly enough, these PCHs are really small. Like, I wouldn't have thought how small they are, but yeah. There's a lot to check for us here on this board, and I've gotten some pictures already from the owner of what he has found. And let's go under the microscope, and I will show you those things first. There will probably be just a lot of things that have a big hole in them, but let's see. They might not. They might have just failed in a different way, like internally, where you cannot see it. And I can see damage here. This is between the PCHs. It seems like there had been physical damage. Like, I don't know if there was ever a component there or not, but these resistors also seem like they have gotten something. So let's continue the search. So the previous owner also did some work on this board with hot air and some flux. As you can see, all of this area has been fluxed up. This is close to the PWM controller at the top left of the board. And this flux really looks like it's corrosive flux. And he said that this MOSFET gets very hot also. Here we have our PWM controller. So we will definitely also have to clean this board. So let's now go over to the most important step, which is to measure the resistance of the individual inputs of the ATX power supply. The big problem is that there's no protection for reverse voltage or something, or over voltage normally on these rails, because those are being done by the power supply itself normally and not by the main board. So there's basically no protection for like 12 volts going into the 5 volts and just blowing everything up. And the biggest problem is the 3.3 volt line. The 3.3 volt line has a lot of very sensitive components that are mostly responsible for logic elements. And if those are shorted, it most of the time kills everything. Like, it kills the SIO, it kills the PCH, or the PCHs in that case, and it kills like the Ethernet sometimes, and the audio and the Ethernet sometimes are on 5 volts, but it can, like, there's just so many MOSFETs that are also working off of 3.3 volts that it can blow up. So let's go and see. We're starting with 3.3 volts. And there you can see it already. On 3.3 volts, we have 2.2 ohms. Let's go on 5 VSB. 5 VSB has 23 ohms. Let's go on, this is 12 volts, I think. No, this is 5 volts. It has 25 ohms. And I think this is 12 volts. And 12 volts seems to have high resistance, which makes a lot of sense, because there's no over voltage happening with 12 volts. If you put in 5 volts into the 12 volts, there's nothing going to happen. But 12 volts getting into the 3.3 or 5 volts does do a lot of damage. So it's time for voltage injection and removing a lot of things. We probably have to remove this controller first here that I've seen with the hole inside. But let's go step by step. Let me get my thermal camera ready and set up so that we can have a look at this board and diagnose it further. So we now have 1 volt at our power supply. Let me show you that. So as you can see, we have 1 volt selected at the power supply. And now we will be bit by bit inputting that into some rails, and we'll be seeing what gets hot with the thermal camera. So let's go into 3.3 volts first. 600 milliamps. That is a lot. Let me quickly find what is taking so much current already. Interesting. I can't really see anything yet getting hot. So I see 2 things that are getting hot, which I think are PCIe switches or something similar to that, right in this area right here. Let's have a closer look. Let's input 1 volt again. And you can see both of these are heating up. So pretty sure that they are bad. And for really testing it out, we will be pushing 3.3 volts now, I think. Let's see. So we now have 3.3 volts, and let's see how many amps this will take. And this is, yeah, this already took 2 amps instantly. And look at these. These heat up quite a bunch. Okay, so these 2 will have to be removed. Let's see if we can see anything else heating up on the 3.3 volts. There's something here also. It might be on the back side. And also up here. Probably something similar. So we now have these 2 to remove. We have something on the back side, it seems, of this. And we also have this big thing right here. This is probably for USB, or it might be for video output. So let's first desolder all of those so we can get rid of these shorts. So this is the first component and this is the second. These two have to be desoldered because these are shorted internally. So let me do that first. I cannot believe this. I blasted this one for like 3 minutes, 450 degrees straight on with 80% airflow, and it is just welded to the board. This is a very bad start because these cannot be removed by hot airing. These have internally welded themselves to the ground pad that they have. And we will have to drill them out. And this is probably going to take quite some while to drill this out. Especially because I need to drill out both of these. And I also have to drill out the big one at the top, probably. So, well then, let me try that. This is already sadly not a good start for this board. And now you can already see the damage, why I wasn't able to remove it. This is like a little bit left of it, and you can see this mark right here. This is the ground pad where it's just burned in deeply. So yeah, continuing to drill this out. So, as you can see, the dark spot there is the drilled out area. If I now supply voltage, you can see that is not getting hot anymore. But our audio controller also gets hot. If you see in the bottom left, that's our audio controller. It's also getting hot. And we still have to drill out that one other one that we have. So audio is also gone on this board, just like that other, I don't know what, maybe a multiplexer. Let me drill that out and let me try to get that audio controller off of the board without needing to drill it out. And now the second one is also drilled off. As you can see, this is the first one and this is the second one. And let's see once again with the thermal camera. So looking with the thermal camera now, I've now gotten rid of both of these components. So we can see these two blue dots right there. These are the two that we have drummed out. And now taking the 3.3 volts again and supplying them. We can see we have lower power consumption, 1.4 amps instead of 2.2 amps like we had before. And those two stay cold. Only the audio controller now is heating up. So next, I will have to take out the audio controller. I will try it with, first I will desolder all of these capacitors that are in here. And after I've done that, I will try to hot air it off. And if that doesn't work, I will have to Dremel it out. I hope that I will just be able to hot air it off, but who knows. I will try. So a little while later, I now got the audio controller removed. All of the capacitors I have removed so they don't blow up my face. And we still have these two removed. Whatever those are, multiplexers or something. Let's now get the thermal camera again, get 3.3 volts and see. So let's see once more for the current. And now we have still 1.3 amps. Let's look what is getting hot also. It's probably still whatever we had in the top. Yep, it's still what we had in the top. Let me flip my phone so you can see that. It is top there. What is still getting hot. Cannot see any other heat signatures for now. And also, is that the MOSFET? There's also a small dot at the top, whatever that is. So it's the big whatever controller, whatever is that is, and it shipped probably in the top left. As you can see, if I apply it, can you see these dots appear? Top left. Also. Yep. So let's go on the microscope and inspect those. So first we have this thing, P13HDX12. Yeah, 20, whatever that is. Let me clean it up a little bit so we can get at least a bit of the marking. So what, 21, 1AZHE. Do I have multiple of these? Are there more of these? This is, I think, the same chip. Right here, let's see. It looks similar enough. P13, P13DPX, P13HD. Okay, this is even different. Okay, so there's different kinds of these. And the other was this one at the top that we had, 3014 GAA. This is the same chip that has the hole in it on the other side of the board. So it makes sense that both of these blow up. So we will have to remove this big thing and also this one. So as you can see, I've masked the area up. Now, protecting the USB and all of that, protecting the CPU voltage and also the capacitors. And now I will be just blasting it with hot air and hope to get it off. So I've now been able to remove that one in the top left, both of these, and I've also instantly removed the one that was in the bottom right here that had the hole in it that we saw. And let's now see for the 3.3 volts how they react if they still have low resistance and are still shorted. So let's look at the power supply. It's still 860 milliamps. That is still way too much for 3.3 volts. So probably it will be too hot for me now to spot whatever is taking the amps because the board is very hot. Yep, the board now needs to cool down in order for us to see those shorts. But what we can do is we can supply that. We can also see for the resistance first. Let's do that. So the 3.3 volt resistance is still basically 0. Still 5 ohms. Let's see for the 5 VSB. And the 5 VSB resistance seems to have gone up. Yeah, 5 VSB resistance has gone up. Let's see, this is I think the 5 volts. The 5 volts resistance has also gone up. So these are good signs. Just our 3.3 volts is still not where we want it to be. Let's check around the SIO for random capacitors to see if the SIO has gotten damaged, because this can also happen very often when you have over voltage on 3.3 volts. And pretty sure our SIO is dead. Look at this. One capacitor has 0.2 or 0.1 ohms. This is basically dead short to ground. And the other side is 8 ohms. So this is probably a dead SIO as well. Let's switch to 1 volt once more, just to be sure, because I'm not too sure if that is the 3.3 volts from the SIO or not. So you can see we have 1 volt, and let's connect it to that capacitor and see what gets hot. And you can see the SIO is getting very hot. Let me apply the macro lens. And if we now look at this, how quickly it gets hot. And this is just with 1 volt. If we now supply 3.3 volts onto here. So we have 3.3 volts, and look at the SIO now, how it will probably glow. There it is. Already at 65 degrees, that SIO is pretty dead. This was what I was thinking about. That when you have 3.3 volts, your SIO most of the time dies as well. Let's check for some other resistances, because I'm curious. Let's see, what is this resistance? Let's go in a little bit higher range. So, one inductor right here. Let's check for this inductor. This inductor, that looks fine. And there's a MOSFET right here, probably for 5-volt dual or something like that. But this has high resistance there on its input side. Also okay resistance. Let's see on this one. This is probably for our PCHs, or one of the PCHs. And 35 ohm looks great. So this next regulator, also kilo ohms, looks great. Next regulator, this has low resistance. Okay, this regulator might have something shorted on it. Let's see, 20 ohms. Yeah, 20 ohms. This might be related to that transistor that blew up. Let's see for the next regulator. The next regulator also has high ohms. Yep, next regulator has high ohms. So the SIO, we already looked at that it has low ohms. Let's see around the Ethernet controller. So the Ethernet controller has high resistance. I just go on both of sides of the capacitors. One is ground and the other one has high resistance. That is good to see. There's another inductor right here. Let's see, that has also high resistance. Yup. Let's see, what else do we have? This is probably all of the V-core side. I would expect that we have high resistance. Yeah, we do. Like, I wouldn't have expected the 12-volt side here to have any damage. And let's see. This is the output of that MOSFET that she said got hot, and this is now high resistance as well. So that is also fixed. Let's go on to the DDR voltages. I will probe these from the back. And this also has low resistance. So one of the DDR, if I'm... Am I on an inductor? Oh no, this is an SMD inductor. Let's see. And this inductor seems to also have high resistance on the DDR side. Yep, so that also looks good. There's an input MOSFET, probably for the 5 VSB. Let's see for its outputs. Output and input look good. So let's check on this inductor right here, where we had very low resistance with 20 ohms. Let's go with 1 volt into there and see if anything heats up then. So we now have 1 volt on our power supply. Let me get my thermal camera and let's go into the general area and let's apply some voltage. And it's a very low draw. It's only 58 milliamps at 1 volt. So this might be fine actually, but I'm not too sure. Because I really don't know what is supposed to be on this line. So it's difficult to say. We will leave this at that first. So I've found something else shorted with 3.3 volts. So we again have 3.3 volts on our tweezers. And now have a look at this. These light up like a Christmas tree. All of them. All 5 of them are shorted. And I was wondering why there's still something getting hot on the 3.3 volt side. And it's all of these PCIe switches. Like, the reflection is pretty bad of my ring light that you can see. But still, all of these are dead. All of these here have to be removed. The board that keeps on giving. So, I gotta be honest. I don't really think there's any reason to go anywhere else with this board. Because the big thing is, our SIO has to be replaced also still. We don't know what else is broken with this. It might be that there's nothing big else broken here. Like, we have found the most important things that are really obviously shorted. So, because you have to think, all of these switches are expensive. These are for, I'm pretty sure, for PCIe Gen 5 switching for the very first slot that is on the board. And these are expensive. I don't even think you could get these. You would only have to take these from donor boards. So let's assess the situation that we have on hand currently. We have missing audio, so all of the audio has to be rebuilt. We have missing these multiplexers. These are probably for PCIe. Might be for these two, might be for these two, can't really tell you. There's another one right here in the middle that I think did not get hot, but let me quickly double check that if this one gets hot or not. Yep, I've just verified this one is not getting hot at all, but we will have to replace the SIO also. These two, we have to replace whatever these two were. Okay, this top one, this long chip, probably is for HDMI and DP. So you could definitely just not put that in there. Don't know what that regulator is that is down up there, just like that regulator down there. We might be able to get those. Don't really know what they are for. And yeah, and then if we've done all of that, we will then have to find out what the hell is wrong with this transistor, why it is there and what it's supposed to do. And then see if anything else is wrong with this board. Like, I really don't know if this makes sense to continue on. I will now check if you can even get that SIO. This is the very first thing that I will now have to confirm and see. And based on that, we might want to look further into this repair. So I was able to find the SIO. This is the SIO that we need. 8 euros plus 350 for shipping. So let's say like 12, almost 12 euros, or like around 12 euros for one SIO. Don't know if I can trust the seller or not, no idea, but it seems to be available. And then there's also these switches. This is the marking on them, 5PR421, and this is the actual part number of them. And these are for DisplayPort 2.4 24GB 4-channel linear red driver with 2.1 mux. Yeah, and you can see this is what we had. This is the package, and these are not available. If we search for this, if we go onto AliExpress and we try to search for that, there are sadly no results. All of these are different items, and also these are not the ones that we need. So these are not available and would need to be taken off of a donor board, and there's 5 of these that need to be replaced. So I've now also removed the SIO, and our short on the SIO line is now gone, where we had like 3.3, where we had like 8 ohms. I think it was something about around there. I will show you now. So to show you, this is now the resistance of the SIO, where we had 8 ohms before, and it removed cleanly. And what I've also done is, if you look at the backside, all of the PCIe switches are off. And the big problem is these are PCIe Gen 5 switches, and these are not available yet. And I guess if they are, they're really expensive. So you would need to get some off of a donor board. So these would be very valuable then. And now I wanted to see if the 3.3 volts has high resistance. And when plugging it in to see the resistance, we can still see that 3.3 volts has still low resistance. And so I went ahead once again to do our usual injection of voltage and take our thermal camera. So we have 3.3 volts. Now have a look here. If we inject voltage, there's another component getting hot. If I remove and now put in, you can see this is an IC. Let me get the macro lens on there so we can see better. And there's the IC, which has basically a hole in it. 88, 90 degrees and rising. It is pretty dead. So yet another chip that we have to remove. There's a IC that has the hole in it where it's burning hot. And let's see for the marking of it. What's this? 5927W330GC. No idea what this chip would do. But we will have to remove it also. So let's quickly do that as well. And another IC removed. Let's see now for the 3.3 volt resistance once more. So let's check the resistance. And the resistance, it got higher, 128. I think this might be fine now. With 128 ohms, I've seen similar readings of boards that I thought were damaged, but might be fine. And now we have 3.3 volts again. And let's put that in and see. And we have about 64 milliamps of power consumption. Let me take the thermal camera and have a look around the board, if there's anything still getting hot or not. So there's yet another IC in the top left corner of the board that is getting hot. But it just heats up very slightly and it might be normal. It's kind of hard to see. Yeah, it's hard. You won't be able to see this. Now you can see it a little bit. If I put it on and off, you can see it getting hotter. As you can see, it's right there. That IC heats up as soon as I put the tweezers on. So I'm pretty sure that this board is sadly gone for. There's so much damaged. I have all of the components right here. So there's just it just went too far, I'm pretty sure. The 3.3 line just took such a big hit, with SIO being dead, audio controller being dead, these two switches being dead, the 5 PCIe switches on the backside being dead, whatever this IC was being dead, this IC being blown just the same as this one in the top left, and then also the display port and HDMI being dead here. To be realistic, putting the SIO onto this board might even be enough to get this working. It might. The big problem is I don't know what this IC is responsible for and these two. Because this, for the HDMI and display port, is not necessary. The audio is not necessary. These two PCIe switches are not necessary. And the 5 switches on the back are theoretically not necessary if you don't want to use PCIe at all. You probably have the only slot that is working is probably then the lowest one here, with this PCIe switch probably still being intact because it does not heat up. So yeah, theoretically soldering the SIO on, you could fit a CPU in here and have it working through the lowest slot here, maybe if these 3 ICs are not needed, but it's very unlikely. And what is even more likely, that there's more damaged here, because we still don't know what this transistor is for that was damaged, and no idea what to, like, I could just place an N-channel MOSFET onto there, which is probably the right thing, but still, we do not know. There's no board view available for this. And yeah, this is sadly just pretty sure a goner. And sadly, I can't help here. So, to have a proper ending to this video, I've talked to the owner, and he has agreed that this board is basically just gone. So I have reassembled all of the heatsinks on here. I really don't know. I probably will leave this as a donor board for myself. And yeah, that's all I can do, sadly, for this board. We've tried a lot. I think we could still learn a lot from this board with voltage injection and seeing how bad it is that when over voltage gets into the 3.3 line, for example. And yeah, hope you still enjoyed the video, have learned something, and one thing I've definitely learned, that these switches that I've drilled out, they were not welded onto the board, but what is actually happening, that X670E, or like this generation of boards, is actually so thick in PCB that you actually have to use a preheater to get some of these off. So in the near future, as soon as I get high-end boards like these, I will always have to use a preheater in order to be able to remove most of the components. Like removing the SIO was a breeze with the preheater. So in future videos, getting one of these boards, I will have to do that. And let me thank again PCBWay for sponsoring this video. And all of my tools are linked in the video description as always. Hope you enjoyed the video. This was Mainboard Medic. Thank you very much and goodbye.